In this video, we're going to have a closer look at the MCS calculations. So to start, we click the Start button. Then we see the project data. If we enter this data, it will be on the PDF report, but we're going to skip this step and just jump into the calculations right away. So the first calculation is the sound calculation. And the first thing we have to enter here is the sound power level. So in this example, 60 dB. And this is the sound power level that you find on a technical sheet of the heat pump. It's important that you use the highest sound power level that is specified, so you cannot use the low noise mode. Second thing we have to enter is the directivity. There are three options, 2, 4, and 8. And here we see an image of the three options. And if your heat pump is installed on the ground against the wall, then the directivity is 4. Next thing we have to enter is the distance from the heat pump to the assessment position. So there are a couple of options here, and the maximum you can select here is 30 meters. So if your distance is more than 30 meters, you can still use the maximum distance of 30 meters. And then we can calculate the attenuation. And this is basically the reduction in noise from the heat pump based on the directivity and distance to the assessment position. Next step is we need to choose the barrier. So is the heat pump visible? Is there a barrier with a partial view or a barrier with no view? And here again we can see some more explanation. So there's also an image here. So in the first image we see that the heat pump is visible. In the second image there's a partial view. So partial view means that at the position of the heat pump, if you move in 25 centimeters in any direction and then you can see the assessment position, then you have a partial view. And if you move in 25 centimeters in any direction and still cannot see the assessment position, then you have a barrier with no view. Then next thing is we can calculate the sound pressure at the assessment position. So again, this is a number that is calculated. You don't have to enter any data yourself here. And then the background noise level, 40 dB. This is a default value. You don't really have to change this number. And then in the end, we can calculate the difference in background and heat pump noise and the adjusted sound pressure level. So in this case, if we calculate, we get 41 dB. And this number cannot be over 42 dB. So if it's not above 42 degree, in this case, that's the case, then your heat pump complies with noise limits at the assessment position. Now let's have a look at the second calculation. That's the HPSPE calculation, or the heat pump system performance estimate. So here we have to select whether it's an existing or new building. We have to enter the EPC number for the building. And here we can look at the data from an EPC certificate. And here we can find the certificate number. So I'm just going to copy it in. And then we have to look for the energy required to heat the property and for the hot water production. We can also find this on this page. Have to scroll down a little bit, and here we see the numbers that we need. So again, I'm going to copy them. Have to remove the comma here. Same thing for the hot water. And then we have to select whether it's an air source heat pump or ground source heat pump. Let's choose an air source heat pump. We can select a manufacturer and heat pump model. Let's use this one, for example. Then we see the MCS certification number. We can select the flow temperature. Let's maybe use 35 degrees, 35. Then we automatically also get the MCS SCOP for heating and hot water. We can select the renewable, what the renewable system provides. So heating and hot water, only heating or only hot water. If it's a hybrid system and we use our current boiler as a backup, We also have to enter the percentage of heating that is covered by the heat pump. If it's a hybrid system that uses a new boiler, we also have to enter the efficiency of the new boiler. But let's say that the heat pump provides heating and hot water in this case. If there here we have to enter if hot water immersion is used. So could be none, could be once per week, could be once per day. Size of the hot water cylinder, let's say maybe 180 liters. And then for the existing heating system, what's the fuel that we use? Gas, electric, or something else? What's the age of the existing system? Let's say some system that was installed before 1994. And here we see the efficiency of the existing system. And then we can make a calculation. And here we see the net energy that is required to heat the property. So this is the number for heating, hot water, and the sum of both. And these numbers are the numbers that we entered in the beginning. So to provide this 10,700 kilowatt hours with the existing system that has an efficiency of 82%, we need 13,096 kilowatt hours. For the hot water production, it's 2,500 kilowatt hours, and the sum is a little over 15,000 kilowatt hours. To provide the same energy, so this 10,700 kilowatt hours with a heat pump that has a much better efficiency and an SCOP of 4.67, we need 2,300 kilowatt hours. For the hot water production, it's a little over 1,000 kilowatt hours, and the sum of both is 3,300 kilowatt hours. Here in the graph, we also see the electricity consumption for the hot water production or for the heating of the building, dependent on the flow temperature. So if we have a flow temperature of 45 degrees, the electricity consumption will be 2,678 kilowatt hours. And if your flow temperature is lower, 35 degrees, the electricity consumption is 2,300 kilowatt hours. And that's also the number that we see here. And then the last calculation is the hot water calculation. Here we have to enter the number of bedrooms. Let's say that we have 3 bedrooms. The number of bathrooms, let's select 1 bathroom. The cold water supply, usually that's 10 degrees. And then the cylinder maximum design water temperature. So that's the temperature of the water in the cylinder. Let's say maybe 55 degrees. And then the heat generator power. So let's say that we have a heat pump of maybe 6 kilowatts. And then we can make a calculation. And then the MCS recommended cylinder size is 180 liters. And the calculated reheat time is 95 minutes. So now we can play around with this a little bit. If the maximum design temperature is a little bit higher, maybe 60 degrees, let's see, then the reheat time is a little bit more, so 105 minutes. And if my heat pump generator power is a little bit higher, maybe 8 kilowatts, the reheat time again goes down a little bit. So this is the hot water calculation, and once we have done all 3 calculations, we can download the PDF report. Here you can select which calculations have to be on the PDF report. Now let's select all 3 of them, generate a PDF report. And then it generates a PDF report with all 3 calculations. So here first on the first page we have the sound pressure calculation. Second page is the heat pump system performance estimate. And here we see also the graph that was generated. And on the last page we see the hot water calculation. And here we see the selected cylinder size and the calculated reheat time.